In this work, we present a system for colorizing an input grayscale image using color photos downloaded from the internet. Our method requires little effort from the user. To colorize a grayscale image, the user first segments the foreground objects using the easy and intuitive lazy snapping technique and adds a text label for each object. Our system then automatically translates the text label to several languages and uses these terms to search for photos in several image sharing websites. To find the most suitable of the downloaded images for our colorization task, our system filters them by segmenting the salient foreground regions and comparing them to the grayscale foreground object in terms of shape, intensity, texture, and dense SIF features. The use of these features leads to color foreground search results that compare favorably to related techniques. Here we show comparisons for several different foreground objects. For colorization of the background, we start with the same set of downloaded images as used for the foreground, since there is often strong correlation between the foreground and background components of a scene. These images are filtered using the GIST descriptor of Hayes and Efros, which gives superior performance at finding background scenes semantically similar to the input. Several comparisons to other methods are shown here. After finding the most suitable foreground regions in the downloaded images, we use each of them to colorize the grayscale foreground object. This is performed by transferring colors from the reference object to the target grayscale object at the resolution of superpixels, using an energy minimization framework based on similarity of intensity, texture, dense SIF features, and spatial position. The colorization results vary for different parameter settings of the colorization energy function. Our system clusters the results from the different settings and retains the two best results from each cluster in terms of energy. The same is done for each of the reference foreground objects, and a similar procedure is used for the background as well. Our system provides a graphical user interface for composing the final colorization result. First, a grayscale image is selected. Our system then clusters all the colorization results into 6 groups and presents a representative thumbnail image from each group in the left panel. Mousing over a thumbnail gives an enlarged version in the preview window and highlights the internet images used for its colorization in the right panel. Clicking on a thumbnail brings the user down the cluster hierarchy and shows representative images of clusters within the cluster. Right-clicking on a thumbnail at any node of the hierarchy saves the image to file. Various colorization results can be generated in this way. Here we show our results for several grayscale examples and compare them to 2 state-of-the-art colorization techniques. The same internet reference images obtained by our filtering method are used for all 3 algorithms, and the best results among the different parameter settings are shown for the comparison methods. Our results compare favorably to those of the other techniques on this wide array of images. We conclude by showing some additional colorization results from our method. Thank you for your attention.